So we're going to now look at the additional exercises in section 8.1 and 8.2. For problems 1 and 2, we want to state the domain restrictions and the vertical asymptotes. This denominator is already factored, so our q cannot be equal to 8, so that would be our restrictions. Nothing reduces here, so q equals 8 will be our vertical asymptote. Now let's look at problem number 2. To get our restrictions, we got to factor the denominator. And so if I look at negative 14, I've got to find two factors of negative 14 that add up to negative 5. And that would be negative 7 and positive 2. So this denominator is going to factor into q plus 2 times q minus 7. Now in terms of domain restrictions, I don't care about the numerator, I'm just caring about the denominator. So I have two domain restrictions. Q cannot be equal to negative 2 and q cannot be equal to positive 7. Now to find the vertical asymptotes, I do need a factor. So we're going to go ahead and we're going to factor that q squared minus 49. And that is a difference of squares. So that'd be q plus 7 times q minus 7. Now in this problem, the q minus 7s are going to divide out to become 1. So we're left with q plus 7 over q plus 2. So our vertical asymptote will have one at q equals negative 2. For number 3, we're just finding the domain. Well, here x cannot be equal to 8. So my domain is going to be all real numbers except for 8. So we'll write that as negative infinity to 8 union 8 to infinity. Make sure we have parentheses around the 8's because we cannot include 8. Similarly for this one, x cannot be equal to negative 5, so I need to write everything except for negative 5 for my domain. So we'll write negative infinity to negative 5, parentheses, union, parentheses, negative 5 to infinity. So for the next one, we want to identify the the horizontal asymptotes. And in this case here, my degrees match. So since my degrees match, I'm going to be taking the ratio of my leading coefficients for my horizontal asymptote. And that'll give me y equals 4/5. So this is falling under case number 3 for our horizontal asymptotes, where the degrees are equal. For number 6, notice that the degree of the bottom is now larger than the degree on the top. So that's going to fall under case 2. My horizontal asymptote is going to be y equals 0. And the last one, degree of the polynomial numerator is 2. That's larger than the degree of the polynomial denominator, which is 1. So that falls under case 1. For horizontal asymptotes, there are none. Now let's take a look at this next one. And here we're asked to graph the functions using transformations. And I'm going to just zoom out here just a little bit. Maybe a little bit more. So now I'm thinking my 1 over x function, and it's been shifted 3 units to the left. Well, this has been shifted 3 units to the right, so actually that would have been if we had g of x equals 1 over x minus 3. This one's been shifted up 3 units, so that's not it. What that equation would have looked like is 1 over x plus 3. Here's our graph that's been shifted 3 units to the left, so it's going to be C. Our answer choice is C. D would have been shifted down 3 units, so that would have been g of x equals 1 over x minus 3. But the correct answer in this problem is C. And you'll see with the graphing on the test, I will probably make most of the graphing multiple choice because doing the graphing in ALEKS, it can be kind of cumbersome to do it, to actually work it out using their system. Let's try this next one. We have 1 over x squared plus 3. This one shifts 3 units up. So this first one looks like it's been shifted 3 units down. So that's not the correct answer. That would have been 1 over x squared minus 3. This one's been shifted up 3 units, so this looks like it's the correct answer. So we'll go and circle that one. This one was shifted to the right 3, so that function would be g of x equals 1 over x minus 3 squared. And this last one was shifted to the left, so that would have been g of x equals 1 over x plus 3 quantity squared, since our horizontal shift is always in the opposite direction. So the correct answer here was B. Alright, let's try this next one. So now we've got a more complicated graph. And what I'd recommend doing is just start going through your graphing technique. So first of all, we want to find the x-intercept. And remember, the x-intercept comes from the numerator. I have an x minus 2, so my x-intercept is going to be 2, 0. Let's do the y-intercept. If I plug in x equals 0, negative 2 over negative 4, that reduces to a positive half. And let's just use the intercepts information, see if we can eliminate some graphs. So if we look at graph A, it has the correct x-intercept, but not the correct y-intercept. All right, so we're going to toss out A. Look at B. It does not have the correct x-intercept, so I'm going to toss those out. Looking at C, it does have the correct x-intercept and the correct y-intercept. So C is still in. D does not have the correct x-intercept. So it looks like my answer choice should be A. Let's just verify by getting some additional properties. My vertical asymptote I get from the denominator. That would be x equals 4. And here my degrees are equal. So I'm going to take 1 over 1, which is 1. So my horizontal asymptote would be y equals 1. And notice if we check the asymptotes, the vertical asymptote is x equals 4. Horizontal asymptote is y equals 1. So we just confirmed that C is the correct answer. So let's turn the page. And on number 11, there's a typo. Eventually this will get corrected in the workbook. But if you have an old workbook, this may still be showing as incorrect. The problem here is that when this printed, this horizontal asymptote just went in the wrong spot. So let's go ahead and we're going to fix that. Horizontal asymptote should be up here. So you want to go ahead and make that correction if it's not already corrected in your workbook. So now let's go ahead and let's build the function. So first thing I want to do is look at my x-intercepts. So my x-intercepts, I've got 2, 1 at -6 and at 0. So their corresponding factors would be x and x plus 6. And remember, the x-intercepts gives me the numerator. So I already now have the numerator. Next, to build the denominator, I'm going to use the vertical asymptote. My vertical asymptote is x equals -3. So that gives me a factor of x plus 3 in the denominator. So we're almost there. And let's be consistent because Alex always labels these as points. So I'm going to rewrite them that way. Make the Alex gods happy. Now, we do have a horizontal asymptote. Now, the only way you can have a horizontal asymptote is if the degree of the polynomial numerator and denominator are the same. As it's written, they're not. The only way I can make them the same is putting a squared here on this x plus 3. So now they both have degree 2. If I multiply both of them out, I'll have an x squared on the top and x squared on the bottom. My horizontal asymptote would be 1 over 1, which equals 1. However, if we look back at our graph here, my horizontal asymptote is y equals 2. So to fix that, I need to put a 2 in front of this. So that's now my function. All right, let's try this next one. So here I'm going to go after the x-intercepts. Got one at -2 and one at 0. So the -2 gives me a factor of x plus 2. The one at 0 gives me a factor of x. And that gives me my numerator. So let's go ahead and build the denominator. So I have two vertical asymptotes in this case, one at -1 and one at +2. So my vertical asymptotes will be x equals -1 and x equals +2. So that's going to give me two factors of x plus 1 and x minus 2. And then finally, our horizontal asymptote looks like y equals negative 3. So again, if I multiply this out, I'm going to have an x squared on top. Multiply this out, I'll have an x squared plus a bunch of terms on the bottom. Ratio of the leading coefficients would be 1. But my horizontal asymptote needs to be negative 3. So I'm going to have to multiply this by negative 3. And so that would be our rational expression.